Hi, welcome to the next video. That means video 2. Okay, wherein we're going to see the setup in DWSIM. Okay, what is our interest? Interest is heat exchanger definition. Heat exchanger definition. We require two streams, that is one stream is a hot stream, another stream is a cold stream. We want one stream to be cooled and one stream to be used for cooling. That means one is hot stream, one is cold stream. So that is how we try to see the setup in the DWSIM. The platform or the window you are seeing is based on the is in the DWSIM, and the let me rub this out. And the version, you can see the DWSIM, about the DWSIM, you see this is 8.4.3. You can see the version here. This is written here. This is known as, this is 8.4.3 version. Okay. I am working in this particular version of the DWSIM. Open source process simulation, modeling and optimization. This is the DWSIM, about the DWSIM. Let us click this OK and then cancel this annotation and then click OK. Now let us start the new. And if I say new, the windows pop up. And this is number one is the simulation configuration wizard. In the simulation configuration wizard, there are introduction, compounds, property packages, system of units, and behavior. So these are the requirements we need to give as input. So let us say next. So this is welcome to the simulation configuration wizard. Click next to continue. Click wizard and go to the simulation configuration window. This is also same. So now go to the next. Now we here in this place we need to set up our or define the compounds. Then you can see here what is written. Select the compounds. You can see this is select the compounds that you want to add to the simulation. Use the text box to search and select a compound in the list. So this is what, click next to continue. Okay, so this is again one more. We are in the second part of the simulation configuration window, wherein I press here Toluene. Okay, let me take this Toluene. The spelling should be correct. So if I say next, will it take automatically? No. See, now I have to go to back. Toluene is not selected. That means I have to click this particular, and then now you can see here the Toluene is selected. Now I search again Styrene. See, Styrene is there. This checkbox, the checkbox, what you see here, this is to be clicked. That means they should be clicked here. And then now you can see that Toluene and Styrene are added components in this. See, these two are added components for this Toluene or for this particular simulation. Okay, this is what we have done as of now. Okay, now click next, and then we'll select Peng Robinson. And VLE is by default, VLE is given here. VLE, because this is liquids and we are interested in only if there is any vaporization, it can be vaporization to that point. And then I click what you call, let us go to this place. I click add. So our property package is added. Now I see next. In this, see, we entire problem specification English units. So degrees Fahrenheit, the pressure units is different. The pressure units is different. The pressure units is PSI. I'm unable to change anything. So let me go to the C5, and then this is Fahrenheit, and then this is PSI, pounds per hour, pound moles per hour. See, all these things are given here in terms of whatever. The length is also very important to us. You can see many things here. The length is given in feet, and then temperature Fahrenheit, pressure is in PSI, mass flow rate is pounds per hour, pound moles per hour. So we are interested to understand these things in this, but this metric cube per hour is there. We can say liters per hour or feet cube per second or feet cube per hour. This is not that important. We can actually skip this, because in our problem, our pressure is given in PSI, mass flow is given in pounds per hour, like that. Okay, let me actually add that what you call problem also here. Let me check the problem. Yeah, let me show you the problem specification also, so that you know the whatever we have done. See, this is the problem specification. See, this is in pounds, Fahrenheit, and then PSI. And the inches now is, oh, this is in inches. Inside the eye is in inches. So we need to be very careful. And the length of the tubes is in feet. Okay, this is also one of the requirement is here. So coming back to our configuration wizard, so you can see length is in inches, molar flow, other things are there. But you know, while specifying, we need to convert to the correct consistent units and then go ahead. Now I'll go to the next. This is enabled here. Now done. Our definition of the toluene, styrene, the compounds, the streams are defined. That means the process fluids are defined here. What we have defined? We have defined the process fluids. Obviously, this is toluene. Toluene is entering at what place? Toluene is entering, and then we have defined styrene. Styrene, right? So these two are the process fluids we have defined, and the toluene is entering at 100 degrees Fahrenheit, and the toluene is entering at 100 degrees Fahrenheit, and styrene is entering at 300 degrees Fahrenheit. Obviously, by looking at these two, we can understand that toluene enters the heat exchanger on the tube side, and the specification given is to heat transfer the heat to a toluene feed stream. We are transferring the heat to toluene. That means this will get heated up and this will get cooled down. So this is the entire. So this becomes the cold stream. This becomes the hot stream. This becomes the cold. This becomes the hot stream. And this is entering in the tube side. This is entering in tube side like this. This is entering in tube side. And this is entering in shell side. Okay, this is entering in shell side. So this is shell side and this is in tube side. Okay, so these are the definitions and we made. Okay, now we'll bring the what you call exact heat exchanger here. Done. Now the next part is define the heat exchangers. Now take the exchangers and then click here and then bring it here. So this is the exchanger we have done. And then zoom on. So this is what it looks like. Let us arrange this properly. This is shell side fluid and this is tube side fluid, right? So this is shell side and this is tube side. So the shell side, the heat exchanger, the streams, what you are seeing is 2 and 4, and the tube side, what you are seeing is so this is the tube side. So tube side, let us define. This is solving in. I think we're able to see what I'm trying to do. And this is solving out. Okay. This is stream number 2, styrene in. Stream number 4, styrene out. Wonderful. So we have defined the property, the compounds. We have defined the thermodynamic package. We have given the system of units. Then we have built the flow sheet in the DWSIM using the modules. That means under the exchanger, we have taken the heat exchanger. You can see heat exchanger. There are cooler, heater, heat exchanger, air cooler to falling film evaporator. We have taken the exchanger. Let me save this as simulation of heat exchanger 01. Okay. Simulation of heat exchanger 0 1. So I have saved this heat exchanger. Now, very important thing is just go to the settings and then Toluene. You can see Toluene here. This Toluene, we need to look at any compound. Suppose say I want to see its properties. Now view selected compound. Now view selected compound. If I look at, I will get these properties. That is also very important part to understand. See, this is the properties of the toluene. See the molecular, there is a structure and it is giving formula C6H5CH3. All other things are given here. The total structure is also given. Now the constants, compound type normal, ID, CAS number, molecular weight is given here. And I'm interested in boiling point. See, normal boiling point is given is 231.152 Fahrenheit. Okay. So this is the toluene. Okay. And then you can see liquid phase. See, it is all the properties are given here. You can see all the properties are shown here. And then let us look at the styrene part now. Styrene, go to the view selected compound. And this is with respect to the styrene. The boiling point of the styrene is 293.288. That means styrene has higher boiling point than when compared with the toluene. So if I look at the toluene here, see, you can see the toluene's boiling point is 231.152, and whereas styrene boiling point is less than that. Okay. So I think I'm making some sense here so that you are easily able to understand better. Right? Right. We'll go to the next video and then understand the giving inputs and then to the streams and then inputs in the shell into heat exchanger as per the problem specification. Hope you have understood how to set up the flow sheet. That means in a flow sheet window. See, this is a flow sheet window here. If it is Dynamics Manager, this is a flow sheet window. And we can set up this, what you call total entire heat exchanger in this one. And material streams also we can actually understand, but we have not specified. And if I say, if I take this as, this is master property table. If I look at this, I say toluene in and toluene out. Okay. And then I want temperature, pressure, mass flow, and of course the temperature is part I have taken, temperature, pressure, and mass flow, which I have taken. So if I say like this, see, this is all available with us, temperature in, temperature out. So if I take this out, so now it is temperature out. Oh, toluene out. Let me separate this and then only bring styrene in, toluene out, styrene out. Now let us see. See, styrene in, styrene out, toluene in, toluene out. You can see. See, this is the entire property table which we can build while working on this particular master table or the heat exchanger simulation design. So this is as it is, we have not given any input. So by default, it has taken something. Chalo, we'll see in the next video how to give all the inputs and then run our simulation.